Okay, so this one's slightly more of a challenge, this one, right? Because we've got y equals x squared minus x, right? But we do the same thing as usual, draw a sketch of a curve, general point P with my x value here. Of course, then my y value then will be just x squared minus x from the equation here. And then for point Q, we move a little bit across, don't we, to the right of distance h. So we've got x plus h. To get the y value then, let's finish this off, you put the x value into the curve here, so we've got x plus h all squared. Okay, that's what it's saying there, because we want to square the x value, so we're going to square this, and then we need to take away the x value. Okay, can I ask you to be careful here, because we've got to take away the x value, which is this. It's best to put this into a bracket, okay, because you need to appreciate that when we're taking away the x value, we're taking away this here, we're taking away all of it. So that minus will apply to both terms, right? Not just the x. So that's why putting in a bracket will help you to remember that the minus applies to it. So that's quite a large coordinate there, isn't it? Okay, for your x and y value. But then when it comes about to doing the gradient of the chord P to Q, as we normally do, so rise divide by step, difference in y's, okay, which is y2, take away y1. Okay, so obviously this would be my y2, all of this here. So x plus h all squared, take away the x plus h, that's my y2. Okay, take away then my y1, which is all of this. And again, as the discussion earlier on, because we want to take away y1, this is my y1, I want to take it all away, I want to take away all of this, put that in a bracket. Okay, because the minus y1, the minus has got to apply to all of that y1 there. It's got to apply to both terms. Okay, so that's why it can get slightly tricky if you don't use brackets. Okay, in this particular case. Bottom is easy though, isn't it? Because x plus 2 is just x plus h. Take away x1, which is just x. And that's nice. Always get that. And of course the x is cancelled, so you're just left with h on the bottom. We can obviously write this out then a bit fuller. So x plus h all squared is x plus h, double bracket, foil on that. Now let's be careful here, because you've got minus of this, yeah? The minus applies to each term. So minus x, of course it'd be minus h as well, wouldn't it? And again here, let's be careful with this. You're taking away the y1, which is this. The minus applies to this, so it'll be minus x squared. Okay? And then the minus applies to the minus x, or minus and a minus will make a plus, when it's be plus x. Okay, all over then of course your h. Right. So we've got then things that will cancel on the top. Of course, you've got minus x there will cancel with the plus x. That's quite nice. We see that quite usually with differentiation with first principles. So then we'll do FOIL on this double bracket. So you get x squared is the first, outers is xh, inners is hx or xh again, and last is h squared. Take away the h, take away the x squared, all over then the h. Of course, again, there's things that will cancel. That minus x squared at the end will cancel with that x squared here. So we end up having on the top 2xh plus h squared minus h over h, right? So then what what I usually do is I look at the top here and can see h is a common factor, so take out h. H of course then times 2x will give me 2xh. H times h of course will give me h squared, and then h times, to get minus h I just need minus 1 in here, don't I? So then I get minus h when I times out. Essentially what I want to do is I want to divide the top by h, and by factorising out a h I can see the h's will cancel. Okay, so I'll divide top each term by h effectively, so I get the gradient of pq is equal to 2x plus h minus 1. Okay, but I don't want pq, don't I? I don't want that chord. I actually want the tangent of p, okay, which the gradient like that. But what I can do is I can get q to get ever so close to p, okay, so you can see that chord then, the chord, as q gets closer and closer, the chord gets ever more like the tangent, and in fact, if you get h to be 0, it will become the tangent. So we say then that dy dx, which is the gradient of the tangent, is what we get when we do the limit of h, when we limit h to 0 of 2x plus h minus 1. And of course then that h will go to 0, that will disappear, h will be 0, so you get 2x minus 1. Okay, that's our answer, which is what you'd expect, isn't it? When you look at that there, when you differentiate, there's 2x that will become, and that becomes of course minus 1. Okay, this is exactly what we wanted, so you can check to see if you got what you needed. It says then, find the x coordinate of the point in the curve y equals x squared minus x, where the gradient of the tangent is 3. So notice the gradient of the tangent is 3. In other words, when the gradient function, dy dx, is equal to 3. Okay, so you just set the gradient function equal to 3, because that's what the gradient is. And of course, gradient function is 2x minus 1. Put that equal to 3, and then you can work out what the x coordinate is. Take the minus 1 over, it becomes a plus 1. So 2x will equal 4. So that means then x will equal 4 divided by 2, which is equal to 2.